Hello and welcome to ICSE Class 8 Physics tutorial. The topic is spherical mirror. Let me start today with a quote by Socrates. He says, "Be kind, for everyone you meet is fighting a hard battle." और अब आइए आपको एक शायर की दो लाइन सुनाता हूं। शायर कहता है, मिली हवाओं में उड़ने की वो सदा यारो, मिली हवाओं में उड़ने की वो सदा यारो, कि मैं जमीन के रिश्तों से कट गया यारो, कि मैं जमीन के रिश्तों से कट गया यारो। एक और शेर सुने। फिर हमको एहतियात से चलना भी आ गया, फिर हमको एहतियात से चलना भी आ गया, ठोकर लगी गिरे तो संभलना भी आ गया, ठोकर लगी गिरे तो संभलना भी आ गया। थैंक यू। Today's topic is spherical mirror. First of all, the first question we are going to take is, define a spherical mirror. Define a spherical mirror, right? So first, the definition of a spherical mirror. A spherical mirror is a reflecting surface. Very simple definition. A spherical mirror is a reflecting surface which is the part of a hollow sphere. Very simple definition. A spherical mirror is a reflecting surface which is the part of a hollow sphere. See, here is a hollow sphere. This is hollow. Alright? And you are taking this section, you are cutting, and you are taking the part of this hollow sphere. Alright? This is a hollow sphere, and you are taking the part of this hollow sphere. So once again, let's see the definition of a spherical mirror. A spherical mirror is a reflecting surface which is the part of a hollow sphere. So this is a spherical mirror, and this is the part of this hollow sphere. Alright. Now because this has to be a mirror, so we polish one of its sides. Alright. Now see, this surface and this surface, one is curved outwards, bulging, one is curved inwards, that is bent inside. Alright. Now the next question is, state. First let me tell you, because it has to be a mirror, so one of its sides we have to polish. For example, here we have polished. This is the reflecting surface, the surface which is curved inwards, bent inside. The bulging side we have polished, and that is why it is a mirror. No, reflection should take place. Alright. If we polish this side and the reflection takes place from the bulging side, the reflecting surface is bulging side, then that is called convex mirror, and this is called concave mirror. So our next question is, State the types of a spherical mirror. State the types of a spherical mirror. Alright. So there are two types, as you can see. One is this type of mirror and one is this type. Now look at this. Look at this. This surface we have polished, and here this surface we have polished. This is the polished surface is curved inwards, and the bulging surface is the reflecting surface. The reflection is taking place from this surface, which is bulging, curved outwards. And here the reflection is taking place from the surface which is curved inwards, bent inside. The bulging side is polished. Please try to understand, not difficult, very easy. So this type of mirror we call, spherical mirror we call concave mirror, and this type of mirror we call convex mirror. Is that fine? So these are the two types of mirror. Fine. Now the next question we are going to take, define the following. Some important terms that we are going to define. Alright, this will be our third question. Second question, we discussed the type of the spherical mirror, right? We discussed the type, that was the second question. And now the third question we are going to talk. The third question is, define the following. There are different important terms. For example, the center of curvature, the radius of curvature, the pole of the spherical mirror, the aperture, and then the principal axis, focus, focal length, etc., etc. Alright, so one by one, let's talk about these important terms. Alright, the first term is C, the center of curvature of the spherical mirror. The center of curvature of the spherical mirror. Alright. Now see, this as I showed you, this mirror is a part of this hollow sphere. This mirror is a part of this hollow sphere, and this sphere has its center. So that center is called the center of curvature of this spherical mirror, in particular concave mirror, if we talk about this type of mirror. Alright, so the reflecting surface is a part of a sphere. The reflecting surface is a part of a sphere, and the center of the sphere is called the center of curvature of this spherical mirror. May it be concave mirror, may it be convex mirror. Alright, in particular, if we talk about concave mirror, so then we say that the center of the sphere of which this is a part. Alright, so that center, this reflecting surface, this spherical mirror, is a part of a sphere. The center of that sphere is called the center of curvature of this concave mirror. Alright, and we represent that by capital C, the center of curvature. Fine. Now let me show you. Let me show you. Here somewhere there is center of curvature. Alright, because here somewhere there is center of curvature. C. Why? Because your sphere is something like this. Your sphere is something like this, and this is a part of that sphere. Fine. Now the next term is the radius of curvature. So the radius of this sphere, the radius of this sphere is called the the reflecting surface of a spherical mirror is a part of a sphere. The center of the sphere is called the center of curvature of the mirror, spherical mirror, and the radius of the sphere is called the radius of curvature of the spherical mirror. In this case, the radius of curvature of the concave mirror. Alright? So, center of the sphere and the radius of the sphere. Fine. And this is the radius. This is the radius. This is the radius. So this we call the radius of curvature. We represent this by the capital R. By capital R, radius of curvature. Fine. Now the next is pole. Pole is the center of the spherical mirror. The center, the middle. This is your concave mirror, spherical mirror. This center is somewhere here. So this center of the spherical mirror is called the pole of the spherical mirror. We represent this usually by capital P. This is pole, the center of the spherical mirror. Alright? So that is pole. And then next is aperture, then principal axis. Aperture. Now see, the part of the mirror, this much, this is the reflecting surface. This side is polished. If we talk about the concave mirror, so this side we have polished, and the reflection is taking place from this side, which is bent. So this is a type of concave mirror. All right. Now we are going to talk about the aperture. So the part of the mirror which is exposed to the light, that is called the aperture. So here, from this end to this end, this is the part of the mirror which is exposed to the light. Alright, so from here to here, this is called the aperture of the spherical mirror, right? From this end to this end, that is called the aperture of the spherical mirror, right? The part of the mirror which is exposed to the light is called the aperture. Okay, then next is principal axis. Yeah, principal axis. The line, where is it? The line joining P and C is called the principal axis of the spherical mirror. In this case, the principal axis of the concave mirror. The line joining P and C. That means the line joining the pole of the concave mirror to the center of curvature of the concave mirror. This line is called the principal axis. Alright, we can extend this. We can extend this. This is our principal axis, and of course this is C. This is C, the center of curvature. Alright, so principal axis is done. So we discussed the center of curvature, we talked about the radius of curvature, we talked about the aperture, we talked about the pole, and then the principal axis of the concave mirror or the spherical mirror. Fine. Okay. The next is then focus and focal length. Two more terms. Focus and focal length. If I talk about this concave mirror first, then what is focus? Please understand, this is important. What is focus? The rays, the light rays which are parallel to the now this, this is the principal axis because this is the line joining P and C. So the rays of light which are parallel to the principal axis and falling on a concave mirror. For example, this one ray I am taking, right? This is a ray of light. This is a ray which is parallel to the principal axis and falling on a concave mirror. Alright, after reflection from this concave mirror, it passes through a point on the principal axis, and that point we call the focus, or the focus of the concave mirror. Alright, let me talk about only concave mirror right now. Focus of the concave mirror, right? So this is passing like this through a point on the principal axis, and this point we call focus, F. Alright, fine. Then this is focus or principal focus, but we don't call principal focus. Whenever we say focus, that means we are talking about the principal focus, but we don't say principal focus. Focus only we say. Alright. Once again, listen. Focus. Focus is a point on the principal axis. Alright. How is this point? If a ray of light which is falling on the concave mirror and which is parallel to the principal axis, then after reflection from the mirror, this concave mirror, in this particular case from the concave mirror, it passes through a point on the principal axis. In this case, it passes through F on the principal axis. This point F is called the principal focus, or simply the focus of the concave mirror. Let me talk about only concave mirror. Alright, clear? Okay. Now once it's clear what focus is, or what the principal focus is, then the distance between the pole and the principal focus, or the focus, that means PF, is called focal length. PF is called focal length, and it is represented by small f. Alright, these letters in physics are important. Capital, small, they are important, right? So this PF, this is F. This is F. Can I use some other color? Okay, let me use the red color. This is F. This one is F. Small f. Small f. From P to F. Alright. And what is R? R is from here to here. See, R is from here to here. This is R. PC is R. PC is capital R, the radius of curvature. PF is small f, which is the focal length of the concave mirror. Alright? Fine. See, capital and small matters in physics. Here also you can see. Capital F is for the focus, small f is for the focal length. Is that clear? Fine. You can take one more if you want. You can take one more if you want. Suppose one ray coming from this side, falling on the concave mirror. Again, after reflection, it will pass through the same. It will pass through like this. Getting? Fine. So this point is focus. Any ray of light which is parallel to the principal axis after reflection from the concave mirror, it will pass through the focus. And this property, this ray we are going to use for the construction of ray diagram, and we will be calling this rules for the construction of ray diagram, or you may call it principal rays for the construction of ray diagram in the case of the spherical mirror. Alright, so this is clear? Fine. So what we discussed today, we discussed the first question, define a spherical mirror. The second question, state the types of a spherical mirror. The third question, different terms, define the following. For example, the C, the center of curvature, R, radius of curvature, P, pole, aperture, focus, focal length, etc., etc. Fine. Now, if you want me to talk about focus and focal length about this convex mirror also, so okay, fine. Let me tell you. This is a convex mirror, and this is the principal axis. This is the pole P, center of curvature is somewhere here. Alright. Now see, here the parallelly after reflection from the mirror, it actually passes through F, which is the focus, and here it appears to come from that point, and that point we call focus. Look at it, look at it, look at it. For example, a ray of light is falling on this convex mirror. Alright, after reflection it goes like this in such a way that it seems that it is coming from some point here. So the ray of light, in the case of convex mirror, the ray of light which is parallel to the principal axis, after reflection it appears to come from a point on the principal axis. After reflection from the convex mirror, it goes like this and it appears to come from a point on the principal axis. This point is called focus, principal focus, or simply focus in the case of a convex mirror. I hope it's clear now. Fine. As far as the focal length is concerned, of course, it remains the same, the definition. Here also PFF, and here also PF is a small f. Is that fine? Clear? After this, we are going to talk about after this we'll be talking about the rules for the formation of images by a spherical mirror. In my next lecture, the question that we will be discussing is this: state the rules for the formation of images by a spherical mirror. Alright, so there I'll tell you 4 Ds and how after reflection they pass. That is important, and they're not difficult, easy. Okay then, thank you so much. Thanks.